Hello, in this video I'm going to talk about the law of cosines. So the law of cosines, just like the law of sines, it applies to all triangles, not just right triangles, okay? So any shape possible. So it's very, very powerful. Now the law of cosines has, you'll see it often in books, and it'll have three different forms, essentially one for each side. So alpha forms A, beta forms B, gamma forms C. And just like with law of sines, when you do write your triangle, it doesn't matter what order you put your angles in, but what does matter is that alpha forms A, beta forms B, gamma forms C, okay? So now it may look like this is a little bit difficult or intimidating to memorize, but here's what I do physically. I memorize it sort of physically with form. So essentially what you have is the side across the angle, that is squared, and that is equal to, doesn't matter then which side you put next. The other one side squared, then the other side squared, minus 2 times one side times the other side, cosine of the angle, right? So physically, what I think of is, let's say I'm looking at this triangle. Let me take this out from behind. So if I'm looking at this triangle physically, and I'm looking at side C and gamma, the angle that forms side C, well, I realize that also these two sides, in a sense, make up gamma, right? Because if they come in, or if they come in, the angle's narrower or wider. So I look at it as C squared, right, across from gamma. C squared is equal to A squared plus B squared minus 2AB cosine of gamma, all right? If we look at alpha forming A, then A squared is equal to B squared plus C squared minus 2BC cosine of gamma. I'm sorry, alpha, cosine of alpha. And then here, beta forms B, so B squared is equal to A squared plus C squared minus 2AC cosine of beta. All right? So in that sense, I kind of do it physically in that way. To me, these three formulas kind of condense into one, where I realize that I'm really looking at the angle, a particular angle, the side across from that angle squared, and then these two sides that actually are the sides that, in a sense, form that angle. The squares minus 2 times each side. So anyway, maybe that'll help you. So let's take a look at what is the law of cosines particularly good for. Well, it really is good for where the law of sines isn't good. So if you recall, with law of sines, you had to know at least one angle and the side opposite that angle. Well, in law of cosines, that's not necessary. In fact, side angle side, where you know this side, you know this side, and you know this angle, this is perfect. So you could say this squared is equal to this squared plus this squared minus 2 this cosine of that. You're done. The other case that it's really good for is side, side, side. So you know the three sides, but you don't know any of the angles. But with law of cosines, we'll do an example and you can find these angles. Okay? So let's do a couple of examples. Suppose a scientist wishes to determine the distance across the base of a volcanic cinder. Right, so there's my cinder. Distances AB and AC are measured to be 430 meters, 380 meters, make that a little bit, so 380 meters respectively, and the angle here is 85 degrees. So what I'm going to set up is that this distance squared is equal to this squared plus this squared minus 2 this cosine of 85, right? So there you go. Now, I usually put all this in my calculator at once. I tend to make fewer mistakes when I do that. So I'll show you what I do. The first thing I do is make sure I'm in degree mode. Okay. And then I'll put in 430 squared plus 380 squared minus, now it's this minus sign. This is the negative of a number I'm actually subtracting as an operation. So minus 2 times 430 times 380, and then the cosine of 85 degrees. Okay, now that's the square. That's d squared. So now I'm going to take a square root. So I'm going to do square root of that answer. So essentially what I did is I brought down that answer in here. There it is, 548, let's say 0.5 meters. So you get 548.5 meters, and that's what would be here. All right, so that's our first example where we had basically side angle side. Okay, now let's take a look at the another example where we only know all sides, and we're going to find the angles. So here, a triangle has lengths, sides of length A is 17, so let's go ahead and so we have A, which is going to be across from alpha, is 17. Beta, B is 19 feet. And gamma is, forms C, 23 feet. Okay? And we want to know the angles. Okay. So now what we can do is we could say, okay, let's just pick one. Let's say we're going to work with alpha forming side A. Okay. And we're going to say, then, let me set it up. A squared is equal to B squared plus C squared minus 2 BC cosine of alpha. So I'll have A squared is equal to B squared plus C squared minus 2 BC cosine of alpha. Right? So now let's go ahead and fill that in. So 17 squared is equal to 19 squared plus 23 squared minus 2 times 19 times 23 cosine of alpha. Now, when we go to solve that, I'm really trying to solve for alpha, but I'm first going to have to isolate cosine of alpha. So since this is being added, right, I'm going to subtract 19 squared, subtract 23 squared, so I'll have 17 squared minus 19 squared minus 23 squared. And then I have all this, which is multiplying the cosine alpha, so I want to divide it. So I'm going to divide by negative 2 times 19 times 23, and that'll give me cosine of alpha. All right. Now when I put this in my calculator, I again do this all at once, but what I remember to do is put parentheses. Okay. And then here, this is going to be the negative sign that's for a number because it's not an operation. It's telling me this is the negative of a 2. All right, so what we're going to do then is, let's see if I can push this up here. I'm going to put parentheses, and I'm going to do 17 squared minus, now that minus is this one because it's an operation between two numbers, minus 19 squared minus 23 squared. Again, that's the operator. And then divided by, open a new parentheses, and we have, now this is this negative side, negative 2 times 19 times 23, and I can close the parentheses. Now I've got that all in there, press enter, and that's what I get, 0.6876. All right, so I'm going to bring this down again. 0.6876. That's what cosine alpha is. Oops. So obviously alpha is the inverse cosine. Excuse me. And when you put this in your calculator and you're in degree mode, you're going to get that alpha is 46.6 degrees. Okay. Now, so we've just found this 46.6 degrees. Excuse me. We just need to do another angle, same procedure, and then once we have two angles, we can subtract from 180. So go ahead and pause the video and find C. Find C. Or work with C, and so essentially find gamma. Okay. So what you'll have is C squared equals A squared plus B squared minus 2AB cosine of gamma. So you'll have 23 squared is equal to 17 squared plus 19 squared minus 2 times 17, 19, and cosine of gamma. So when I go ahead and do the algebra, I'll have this. excuse me. So when you're done, you should get 1873. 0.1873 is what cosine of gamma is. And so you'll get gamma is 79.2 degrees. So of course now at this point, all you have to do is say 180 degrees minus 46.6 degrees and minus 79.2 degrees will give me that last angle, 54.2 degrees. Okay, so we got gamma was 79.2, and we got the last one is 54.2. Now the last point that I want to make the law of cosines, unlike the law of sines, the law of sines, if you remember, had an ambiguous case. And that was because when you were solving for, let's say, the sine of alpha equal to a positive number, because you're looking for the length of the side of the triangle. And what happened is, you were basically asking for what angle is the y-coordinate a certain length, positive length. And maybe you got this angle. All right, the y-coordinate's this length. Well, there's another angle over here in quadrant 2 that also has a y-coordinate of that length. And both of these angles are less than 180 degrees. So what you could have is the possibility of two triangles in some cases. But look what happens when you're solving for the cosine of an angle equal to a number, a positive number. Well, x, here you're asking the underlying question for what angle is the x-coordinate, this positive number. Well, the x-coordinate is positive in quadrants 1, right, and 4. But the angles in quadrant 1 go from 0 to 90 degrees. In quadrant 4, they go from 270 to what, 360, right? So in this, because of the way the law of cosines works, or cosine works, you'll have an angle in here. You'll get one solution in quadrant 1. The other solution, which would be somewhere between 270 and 360 degrees, would be impossible to use for a triangle because the sum of three angles in a triangle has to be 180 and it can't exceed that. And of course, any angle in here would exceed that, so it would be impossible to have a second triangle. So that's a bit of an advantage because you don't have an ambiguous case for law of cosines. When you go for an angle, bam, you got it, that's it, done. All right? Thanks so much for listening.